Hello, welcome everyone. We still have another minute or two here before we get going. Just wanted to get things up and running for you. So last chance to grab yourself a water or a coffee before we jump in. Okay, well, my clock is showing it's 12 o'clock. We have a lot of content to cover, so I'm going to go ahead and jump in. I first of all want to welcome you all. Thank you so much for joining today. I'm really looking forward to going over some of this content with you and hearing your response and questions. A couple of housekeeping items. If you would like a PDH continuing education certificate for attending, please do email me. I've put my email in the chat already. And please do use the chat feature for any questions that you have along the way. I've run through this presentation. It is chock full of information. I'm hoping that we'll have a few minutes at the end for Q&A, but in the event that we run out of time, I will take all of those written chat questions and I'll follow up with the entire group so that everyone can benefit from all of the questions and responses. So I'll quickly introduce myself and we'll jump in here. My name is Claire Gandee. I'm the Technical Sales Manager with the Building Products Group here for North America. And primarily my job is to work with structural engineers on various types of applications. My background is in structural engineering, though I've been out of consulting for probably longer than I'd like to admit. And with that, I will go ahead and jump in. Thank you again for joining today, and I hope you enjoy. So let's begin with a quick agenda. First, I will review what the Geramic steel fibers are and the code implications of using them in the context of these structural applications that we'll be covering today. I am talking about slab on grade as the first item, realizing these are typically non-structural elements. It is really important just to give you a quick overview. This is the biggest usage of steel fiber reinforcing, so I wanted to at least make sure that you understood that before we move on to the more advanced applications. The third being floors on piles. Next, we'll move into structural mats, ASRS, and outdoor mats and pavements, followed by our SigmaSlab solution, which is the combination of post-tensioning and Dramix. Next, we'll move into composite deck applications, including Diaphragm Shear. Then shear wall link beams. And we will end with an R&D spotlight on tilt walls and follow up with closing and hopefully a few minutes for Q&A. So let's start. What are these Geramic steel fibers? So first of all, these are a cold drawn steel, and it's what's known as a type 1 steel fiber. So for those of you who maybe aren't as familiar with fiber reinforcing, there's a categorization. It's ASTM A820, which groups fibers from type 1 to type 5. And what a type 1 fiber means is that it is cold drawn and that it is an engineered product. So this is something that most often will contribute to post-crack flexural performance, improved shear, and other types of structural contributions as well. It can replace traditional reinforcement in concrete, and it does provide a three-dimensional reinforcement throughout the section matrix. What these steel fibers can do is improve several types of properties of concrete, right? The post-crack tensile strength, flexural strength, shear strength, stress redistribution, crack control, durability, improved fatigue, as well as impact and abrasion resistance, and provide, what fibers are really most well known for, which is crack control, and in addition, fire resistance. However, even though fiber reinforcing and specifically Dramix provides all of these excellent benefits, it's just worth noting what it doesn't do. We do not typically account for any improvement to the compressive strength, right, your F'(C), or the modulus of rupture, or the elastic modulus of concrete. These are properties of the concrete specifically, and so you would expect those to remain unchanged. Within the Dramix brand, we have 3 product lines, the 3D, 4D, and 5D fibers. 3D is our legacy product. These have been around for about 40 years. The naming 3, 4, and 5 in those names corresponds to the end anchorage. So it's the number of segments in that hook at the end. So 3D was a single hook, 4D is a double hook, 5D is a triple hook. In addition to those deformation differences, they also have different tensile strengths. So in combination, they do then tend to be used in different types of segmentations of applications, right? So 3D is going to be more light structural requirements, temperature and shrinkage, and some flexural for sure. 4D fibers are really in a huge expanse between 3D and 5D. These can be heavy-duty slabs and pavements, composite deck, slab diaphragms, jointless floors, as well as lightly reinforced floors. You can also use 4D fibers in high dosages in structural mat applications. So they kind of span a pretty big spectrum. Finally, the 5D fibers are going to be our most high performing structural type of application. So this is going to be our floors on piles, structural mats, structural members in general. And I put at the end here, tilt walls, question mark. We'll talk about that at the end. This is something that I discuss with every single person who will listen. It's really important to know that there are 5 factors that are going to influence how a steel fiber performs as part of a SFRC, or a steel fiber reinforced concrete. Of course, the concrete itself can't be ignored, but for the purpose and context of this conversation, I'm just going to focus on the fiber properties. So it's the tensile strength of the steel, the anchorage mechanism, the aspect ratio, which is the length of the fiber divided by its diameter, the length itself, and the collation or gluing or distribution method, the way to ensure that you get this consistent distribution of the fibers. So it's really critical that you have an understanding that it's not any one of these factors in isolation, but really the combination that will determine how it will perform. So in order to quantify that, the standard that we use here at Beckart is a European approach. It's the EN 14651 test. It is loosely correlated to the, ASTM, the C1609 beam test. But in any case, this 14651 test, this is a notched beam test with midpoint loading. And the way that it works is, as you apply load, you measure the crack mouth opening, right? You have that notch in the center, so you know where the crack will propagate from. And so the CMOD values that you see there, that stands for crack mouth opening displacement. And there are 4 preset data points that you log at 0.5, 1.5, 2.5, and 3.5 millimeters. And those all correspond to a specific load. From that, you can determine stress values, the FR1, 2, 3, and 4 that correspond to that. And so it's very important that you use those types of performance metrics to characterize how that SFRC is performing when it comes to post-crack flexural and toughness and so on. Now, why, oops, let's see if we can get back here. There we go. How does this work, right? When we're actually doing our calculations, this is simplified, but generally speaking, right? We need to take a way to find that flexural stress to convert it into a tensile stress such that we can determine what is the moment capacity of this section, right? Because that's ultimately what we're trying to calculate in this particular example. So we take the raw data in this top middle image here, like we saw in the previous slide, and simplify it into what I've highlighted in yellow in the center, a constitutive or simplified model of that same data, that trapezoidal shape. So now, for those of you structural engineers on the line, when you think back to your stress strain diagram and establishing what is the section capacity, right? Now, in addition to whatever reinforcing might otherwise be present, now we have this trapezoidal stress contribution that the steel fiber reinforced concrete participates in tension south of the neutral axis. And that trapezoidal shape here is directly related to the testing values that we just saw in the previous two slides. The reason I'm going through all of this is because I think it's really important that we understand where these values are coming from, and also to understand the nature of how the dosage, the fiber, the concrete mix, and all of those performance characteristics that I mentioned, how they all play together. So, if you notice the, for example, if we're looking at the FR4 values, that's corresponding to like your ultimate strength condition, your ULS. So let's say that I've specified a project which needs 600 PSI FR4 value. So there's a number of different combinations I could use to get there, right? I could use, if I'm using the 40 fibers, I could come over here and pull off, eyeballing it, maybe about 49 pounds of the 4D 6560 BG fiber, or next to this blue line over in the top middle, that looks to be about maybe 40 pounds of the 5D 6560 BG fiber in 4,000 PSI concrete, or moving to the top left, this kind of yellow-orange line, about 35 or 36 pounds per cubic yard of 5D 6560 in 5,000 PSI concrete. So using a performance-based specification will help ensure that whatever the design intent will be met, regardless of any specific dosage specification. Okay, so that was a lot talking about flexural, but of course there are other improvements. I alluded to some earlier. One-way and two-way shear are other improvements that you can expect to see. We have a, looks like a little bit of an issue on the conversion of this slide. Sorry about that. But essentially what the purpose of this is to show is that the propagation of shear cracking is minimized. The width of the crack and the length of the crack are for sure improved when you use steel fiber reinforcing. And in addition, for a two-way punching shear application, you can consider up to a 40% increase in punching shear strength based on our Iatmo report, which I'll talk about in just one moment. That does lead us right into this discussion of codes, right? How does this all fit within the governing code requirements here in the States, right? IBC and ACI 318 being the codes that we would rely on, they don't really have a lot of explicit documentation about how to use steel fiber reinforcing. And so as a result, we do rely on third-party testing, right? So that would be Iatmo that I mentioned a moment ago, Icces, and UL approval, right? And so just bringing up, right, the way that the IBC states this is it's not excluding the use of alternative materials that are not explicitly specified or adopted in the code, but we want to make sure that we're meeting the intent of the code and that you have approval such that the building official will approve the use of this product. And that is exactly where the Icces and Iatmo reports come in. So we do have an extensive and comprehensive Iatmo report. It's report number 465. This is the basis of which we are using these steel fibers in all different kinds of both structural and non-structural applications, and the de facto code approval that you would need. Now, this slide kind of doesn't fit here, but I couldn't really find a better place for it. So bear with me. But essentially, I really have been getting a lot more questions about, well, what's the carbon contribution? What's the embodied carbon? Do you have an EPD? This is coming up a lot more in conversations that I'm having with structural engineers. I think that this is something that's only going to be gaining in popularity and further conversations that we have. So I did want to make a comment about this, that you can actually get some benefit from using ceramic steel fibers in projects as it relates to sustainability and embodied carbon, right? One way is because these designs are optimized. They are often thinner, which means less cement use, which is a huge offender, less rebar and mesh. All Geramic steel fibers are manufactured with at least 15% recycled content, and all Geramic steel fibers are 100% recyclable. We do also have an EPD, so should you have a project where you'd like to consider what would be the impact of utilizing this towards a sustainability goal, just let me know and we can review that. All right, so all of that is kind of that umbrella to kind of introduce you to Dramix. That is super fast. I know I'm going really fast because there's so much to cover, but if you want to talk about or learn more about anything, just let me know, and we're happy to schedule something like a lunch and learn and kind of go a little bit more of a deep dive into any one of these topics, and or anything generally speaking related to steel fibers. All right, so let's talk about slabs. There are several different types of slabs, but we're in all different kinds, right? Saw cut, conventional space saw cut floors, jointless floors, which can go up to 165 feet, construction joint spacing without saw cuts, and seamless floors, which would have no visible joints, and that would be a combined solution with rebar or mesh or post-tensioning. To give you a sense of scale, we're placing on average about 150,000 square feet of Dramix reinforced floors per day in North America. And I shouldn't say that we're placing it. We don't self-perform. Maybe a better way of putting that would be to say that 150,000 square feet is placed with Dramix. All right, and why? Right, so a few key points. Steel fibers are going to provide a homogeneous reinforcement rather than a 2D planar reinforcement. So it does create a composite material as it's a three-dimensional reinforcing throughout the full depth of your concrete section. So you're going to get much better ductility, durability, and flexural capacity. And you also are avoiding unreinforced concrete cover, which is usually, where you would have spalling at the top of your slab section. And there's less risk for human error, right? The concrete is pre-reinforced, so if the guys out on the site are standing on the reinforcing and the chairs, slip out, or maybe, the right reinforcing doesn't get placed or doesn't get placed at the right spacing, all of those concerns are eliminated. I alluded to this a moment ago, right? Because you don't need a cover, you can also actually get a thinner and more optimized section. We're using high performance steel fibers with a full depth uniform distribution. And so you can actually increase the load carrying capacity while thinning the section. So one of the ways that we're often providing cost savings is by offering a thinner slab solution. Or in a different way of looking at it, you could keep the same slab depth and increase the capacity of that flooring system. So for example, in a warehouse, you might go from a 32 or 36 foot clear height to a 40 foot clear height with the same slab thickness, but now using Dramix. So it's just different ways of approaching how you use that solution. And then finally, the coordination headache of reinforcement and post-installed anchorage. I think we've all had calls from, maybe it's Hilti, maybe it's Simpson, whoever the folks are on site, maybe drilling into rebar. So in the absence of rebar to coordinate with, you have a much stronger and easier approach, which is one of the main benefits that folks really are able to realize when using this type of approach. All right, enough about those. Let's get into some more structural applications that we're all here for. So I have pile supported slabs, and I have pile in quotation marks. This is to cover all manner of soil improvement, right? So this could be rammed aggregate piers, helical piers, CMCs, whatever the actual soil improvement approach that you're using. I'm loosely generalizing all of them as piles. So because of the 5D fibers that we have, those structural fibers, we can provide a structured slab approach for these discretely supported slabs. Now, these are not technically a structural element in the sense that they're not supporting the building above, but they are structured spanning from support to support. And so we do have to count on the real strength and the strain hardening performance that we can get from the 5D fiber. So I have a case study to introduce you to how this came into play in a real world example. So this was a project we did with Menard. This is a 50,000 square foot, roughly, warehouse where it had a 700 PSF floor loads, pretty significant, with 140 kip column loads, and it had the soil conditions had a thick and very soft marshy deposit. The excavation and disposal of those materials, because they were contaminated, was extraordinarily expensive. So the hope here was to minimize the amount of material that had to be excavated and put somewhere. So the options that were considered, right, a conventional slab on grade supported on CMCs with a very thick LTP or load transfer platform, about 4 feet thick, which would have required removal and treatment of that contaminated material, or a structured slab with conventional reinforcing, which would have been significant. So in this case, we were able to come up with a really nice creative solution. This was a 15.6 inch diameter CMC solution on 9¼ foot grid spacing. It had only an 18 inch LTP thickness, and we were able to do this with a 7 inch slab with 50 pounds per cubic yard of our Dramix 5D 6560 BG fibers. This met all of the project performance criteria. It fit in the client's budget. It was on average about $2 a square foot cheaper than the thicker LTP and slab on grade solution when you took into account the total construction cost, the excavation, and so on. So this was a real win for the project team. We continue to do work like this all the time. You see a very happy cat. Hooray! And this is what it looks like, right? When you construct a floor like this, it basically looks like a slab on grade, right? You come in and do your soil improvement work, you lay your slip sheets, you can then use a laser screed. So a lot of these projects now, especially coming up with the higher floor flatness and levelness requirements, the use of a laser screed can certainly help you achieve that, and a fiber solution can help make the use of a laser screed possible. We're still going to see good detailing practice in a project like this for sure. We want to see reinforcing around interior columns, re-entrant corners. In an interior column like this, we want to see a circular block out, compressible material, right? The same kinds of things that you would do ordinarily. And then you end up with a really nice joint-free solution. I believe there's only one joint in this 50,000 square foot project. All right, so let's move on now to structural mats, ASRS, and outdoor projects. So, right, what is the point of a structural mat? Just kind of laying the groundwork here, no pun intended, right? But any floor slab that's resisting not only gravity loads, but also wind, snow, or seismic, and supporting building element loads, right? That is a structural element. So now we look at something like a mat foundation for an ASRS rack supported structure, for example. And so we would typically see two different ways of reinforcing something like this. One would be primarily fiber only. I use the word primarily. There's going to most likely be some rebar somewhere at the construction joints, or depending on the forces, you know, if there's a significant uplift force at the perimeter based on those rack legs, for example, if that slab is going into a cantilevered upward condition, we might want to put some bottom rebar at the edge. So that's why I use the word primarily here with the fiber only option. Generally, though, you're going to follow many of the same detailing recommendations that we use for a typical jointless floor with respect to the aspect ratio and panel size and so on. And this solution might be preferred because it's faster. You don't have any top reinforcing to coordinate with the anchorage, right? A project like this can have thousands of anchor bolts that need to be drilled for. By contrast, a combined reinforced solution would have a continuous top layer of rebar or mesh with tied rebar joints, but you have much more flexibility with the size and aspect ratio of your pores. And this might be preferred because of that flexibility, as well as because there's a working platform for the folks who are out there actually doing this construction, that they can stand on it, that they can work from, finish from, and so on. So two really great options for these various projects. For projects that are outdoors, that will be exposed, just a couple of other items. Essentially, everything's the same, except for you might want to pay attention to, which fiber is being used, what's the expectation on the finish, what aesthetics requirements are there, because I'll talk about corrosion in just the next slide here, but there is a potential for rust stains. These would not be structural defects, but purely aesthetic. So we do have galvanized fibers available, although most often they aren't required. And then additionally, beyond that, managing expectations throughout the process. Anytime you have a project that's cast outdoors, it's going to be, unprotected, right? For weather, for wind, for rain, whatever the case might be. So curing is going to be very important, and we might recommend something like a microsynthetic fiber to help with plastic shrinkage, for example. So every project is different. We would want to work through all of the criteria and details and expectations to provide the most appropriate solution on any given project. Coming back to corrosion, this is a question I get a lot, especially when it comes to outdoor projects. So the simplest way that I find to explain this, the fact that corrosion resistance is actually improved with a Geramic steel fiber solution, is because the steel fiber network is discontinuous, right? If you picture a 30-foot long rebar in your slab, once a corrosive agent gets to that bar and it starts to rust, there's no mechanism that could stop it, and it's going to spread that all the way along its length. These steel fibers are at most 60 millimeters long, which is about 2.4 inches. So if it happens to be touching its neighbor, maybe the next one will, but generally speaking, there is not going to be a widespread propagation of corrosion through your system. Additionally, because of the excellent durability and crack control, you're not going to have entry of those corrosive agents into your slab. And even if the fiber does corrode, because it's steel, even if it does, it's not big enough to exert enough pressure to cause any damage, right? At most, these are about 0.9 millimeters in diameter. And so that corrosive pressure is not enough to actually cause any damage to the concrete. And so for this reason, we're used extensively in very demanding and highly corrosive environments like port pavements and this airport here in Qatar. Just a couple of examples. All right, next, let's segue into our post-tensioning and Dramix solution, which is called SigmaSlab. So the background for this is we've done testing, I say 4+1 test slabs at Virginia Tech, and I'll explain that. This research is co-sponsored by Beckhardt and PTI, the Post-Tensioning Institute. And the original plan was 4 test slabs, T1 through T4. T1 is the control slab. This is a banded uniform slab with rebar. So that would be typical to any kind of flat slab PT project that you might see currently. T2 is a banded uniform approach with Dramix 5D fibers and no rebar whatsoever. T3 is a banded approach with rebar, and T4 is a banded approach with steel fibers. So the goals of this study were kind of twofold, I should say are twofold, right? One being, what are the ramifications of using steel fibers in lieu of rebar in these types of elevated projects? And also, what about a banded solution, which is something that the PT industry, I think, is really ripe for. I've spent quite some time in that market, and so I think that would be a really welcome change. The way that the testing went, T4 far outperformed any of the other slabs. It was a great success. In fact, one of the people in place at testing remarked that that slab just wouldn't die. They just kept loading it and loading it and loading it. It was so incredibly strong and durable. And so as a result of that, the groups, both with PTI-CCL and Beckart, have decided to actually do a 5th test slab. So that's where that +1 comes in. So T5 is in progress. It has not yet been passed, but that's going to be a banded, bonded solution with Geramic. So the first 4 slabs were with unbonded PT. So we'll see what will happen and when with regards to ACI and PTI documents. Of course, those code bodies tend to go kind of slowly with changes, but we're certainly very hopeful. We plan to have an Iatmo report specific to the use of this combined SigmaSlab solution in first quarter 2020. Now, why would we do this, right? These are 2 great systems on their own, and so we're really maximizing all of the benefits of both, right? You get minimized cracking and deflection, thinner sections, reducing or in some cases eliminating rebar, as well as joints, and having really, really huge pores. On the practical side, right, we have reduced construction costs, faster schedule, reduced material cost, right? When you have a thinner section, less rebar, of course, the amount of labor on site may be reduced, and less risk of job site error or safety, and less congestion for follow-on trades. So really a great opportunity of, you know, the whole being greater than the sum of the parts. I feel like this picture is so important just to see how little there is in this slab. There's steel fiber reinforced concrete and there's PT tendons, and it's so simple and straightforward. Now, here's another case study. This was a floor on piles project that originally had a 15-foot pile spacing with a 250 PSF live load, 4,000 PSI concrete strength, and about 140,000 square feet with no joints. So this was reviewed using the Iatmo 465 report that's currently available, and using the Adapt Builder software. That 3D finite element solution has integrated the Dramix fibers directly into it. Beckart, Adapt is now part of the RISA software package. So, you know, if you wanted to look into that. Now, as far as the different options that were considered, right? The original design was a 15-foot pile grid with a 10-inch slab with rebar. And the various solutions that were considered was, 1, keeping that 15-foot pile grid, doing a Dramix plus rebar solution that was 10 inches, a PT plus Dramix solution, right? So a SigmaSlab at 8 inches. Or what about increasing the spacing of those piles to 24 feet? And then we have 2 different options, a PT and rebar option at 10 inches or a PT plus Dramix option at 10 inches. And so how does all of that compare? What you'll see is the blue is the rebar only. The green ones are the 15-foot pile spacing with the Dramix options. And then the yellow-orange lines are the 24-foot spacings. And so what actually happened was we were able to offer about $115,000 savings, about a 9% construction cost savings with the 15 by 15 foot grid and the 8-inch SigmaSlab solution. So it was a pretty stark difference here. And, certainly one that we would expect to see more projects like this coming to pass. All right, so now let's talk about composite decks. Many of you might already know that the Verco and Vulcraft catalog has already been updated to include Geramic steel fibers as an alternative to welded wire mesh for temperature and shrinkage, right? So for that 0.00075 reinforcing ratio, you can use that 66W1.4, for example, or this is an internal copy, 15 pounds of the 40 fibers in normal weight concrete. If you were to go to the Nucor website right now, the dosages are actually different. This is being updated. I have an internal copy here showing for you. So in addition to using steel fibers for temperature and shrinkage crack control, you can also now utilize it for diaphragm shear. This was another testing protocol that was done at Virginia Tech. There is another Iatmo report that Verco Vulcraft completed. That's report number 2018. And based on that research, there is now a new diaphragm shear online tool. That's on the Vulcraft and Verco website. So with that, you can actually just go on there. Depending on what your shear demand is, you can calculate what the dosage is. So you don't even have to contact me to come up with that. That's available to the public. I'm going to be doing a joint webinar on this in September. For those of you who got my newsletter, I said August 24th, and I'm sorry, that's just changed. So just stay tuned, stay plugged in with me on LinkedIn. I'll be sure to post about it there. All right, let's talk about shear wall link beams. So this application is another one that's already been done and currently being done. There is ongoing research to continue to optimize how it can be implemented. The primary variables being the aspect ratio of these coupling beams, the fiber type, the dosage, and the rebar detailing complementing the fibers. The primary intent is to reduce the amount of diagonal shear required in beams with an aspect ratio less than 2 for constructability purposes. And then for longer beams that don't have that diagonal shear reinforcement, they can still benefit from the reduced congestion. So here you see a hysteresis comparison between the blue lines is a conventionally reinforced link beam and the pink is the fiber reinforcing. Now, this is an excerpt from some research, but I've highlighted the part that I think is most impactful for us here. Generally speaking, these high-performance fiber-reinforced concrete, HPFRCs, high-performance fiber-reinforced concrete regions exhibited narrow crack spacing and significantly improved damage tolerance despite simplified detailing, which I interpret as it performed better even though it was easier to construct. So it really is that straightforward. So here's another case study. This was out of a report that was done by Kerry Kopczynski and others. This is a specific project that was done out in Washington State. The project was really interesting. They built 2 different 3D nonlinear models, one with conventionally reinforced link beams and one with the high performance fiber reinforced beams, and used experimental hysteresis loops based on that test data to model the behavior that would be expected. The max story drift was below 2%. And you notice the detailing on the RC beams on the left and the high performance fiber reinforced beams on the right. From a congestion standpoint and a constructability standpoint, it was so much easier to work with those high performance beams. And not only that, it was cost effective. We'll come to that in just a moment. So here's some more images of this. The project was originally called 815 Pine in Seattle. Its name changed to Premier on Pine, as well as the Martin, both of these in Seattle, so extremely high seismic region. If you notice on the bottom right here, the drift performance throughout the height of this building, which I think was around the 400-foot ballpark. So you see really great parity of the overall performance with regards to drift. And finally, the constructability impact, right? So not only do you have less rebar tonnage and reduced labor to construct those cages, but also faster construction and reduced potential for delay because of the conflict, digestion, congestion, and installation issues. And further, it's just more cost effective. The conventional solution for a single beam, the comparison here shows that it was about $2,230 for one beam, whereas the high performance fiber reinforced beam was about $1,560. So we're continuing to do more of this, and I'm seeing more of this coming up. So if any of you are doing towers and would like to look at something like this, by all means reach out. Let's talk about this in a lot more detail than these 4 or 5 slides. All right, and then in R&D spotlight. So I couldn't talk about everything just in the interest of time. I wanted to do kind of a quick overview here, but tilt walls are something that I'm getting a lot of requests to discuss. So in tilt wall applications, the goal will be to use the Dramix 5D fibers as the primary flexural reinforcing as well as crack control. We are doing some testing with a GC out west who's already casting, lifting, placing these panels in their own buildings to provide an initial proof of concept. They noted significant time savings, and they are trying to go, unsurprisingly, taller and thinner. The current height to thickness ratios ranging between 25 and 30. That contractor reported that these fiber reinforced panels were stiffer, that they flexed less as they were being lifted. And they were really, really happy with it. So this is definitely something that we're hoping to do a lot more of. For sure, with our involvement in the industrial market, I see a really great opportunity here, but more research still to come. And with that, we have about 3 minutes left. I want to just quickly thank all of you so much for joining today. Looks like we do have a few minutes for questions. So Mariana, I don't know if there are any questions in the chat for me.
Yes, Claire, thank you so much for sharing this important information. So the first question is from Scott, and he's asking, is this testing available for public review?
Oh boy, well, there's lots of testing. Depending on what it is, possibly, Scott, just go ahead and email me the specific testing that you're looking for. And if it's already been published, I'll be happy to share it with you. And if it hasn't yet been published, then I can just put a placeholder to forward that to you when it's available.
Yeah, he's asking specifically for the Virginia Tech PT testing.
I think that the report has been finalized, so I'll definitely check into that. If it's available to distribute externally, I will absolutely forward that on.
Perfect. Then the second question is from Sinan. He's asking, can we use this software free?
The Adapt software, so nope, that is a software that you would have to purchase it. You would have to talk to RISA to figure that out. If you're looking specifically at Slabs on Grade, Beckart does have some free design tools that are based on a yield line theory. They aren't finite element, but we do have some in-house tools that are available for free. So depending on what your application is and how you're intending to use the steel fiber reinforcing, it's certainly possible that we might be able to provide you with a free tool, but in the absence of that, you would have to go through the commercial resources available and purchase those other tools.
Okay. Then Arun is asking, what about impact resistance in slabs?
Yeah, absolutely. Impact resistance is absolutely increased by using a Geramic solution, but of course it's going to depend on the dosage and which fiber you're using, to what extent. If you're using a very, very low dosage versus a higher dosage, right, it all in some way correlates. But generally speaking, the wear and tear, the durability of these floors is far above an improvement over a conventional or an unreinforced solution. And I'll add to that that fatigue resistance is also a significant improvement that you can expect. So if you have repetitive loads, that's also something that you can see pretty significant improvement in with a steel fiber solution.
Okay. The next question is again from Sinan, and he's asking, what do you think when you compare Dramix steel fibers and microsynthetic fibers?
Right, so they have completely different applications. To lump them together is really not quite looking at them correctly. Yes, fibers have some similarities, but a Dramix steel fiber is used for all different kinds of applications that we've discussed here today, right? Crack control as well as flexural shear, and so on. A microsynthetic fiber, really its only purpose is for the resistance to plastic shrinkage cracking, right? So during the first day or so after the concrete is poured, that is when a microsynthetic would be utilized. And after that, it really doesn't contribute to any of those other structural performance characteristics that I've mentioned. So I would not personally consider the two of them in the same boat.
Okay. Then Terry is asking, what are some practical applications for the PT Dramix slab solution?
Yeah, absolutely. So I think probably the easiest entry into that would be a pile supported floor, or a extended seamless slab on ground. So something where you want to go, 500 feet or something like this. You can use a combined solution. We are working towards those elevated slabs, and when we have the Iatmo report, we will likely do a much bigger push to market for something like an elevated podium slab, where you can really take advantage of the strengths of both components of that system. But for now, the on-grade applications are easy. We have the Iatmo report to support that. And I would say that that's probably the best approach. And what's nice is with a pile supported system, you could approach it with either a flat tendon drape or with an actual profile. So depending on the spacing of those supports and the loading, how we can really maximize the use of the post-tensioning in that application would be dependent on those various criteria, but that can be really effective.
Okay. Then Ruben is asking, in Mexico there have been applications other than floors. Well, the answer is yes, Ruben. If you want, we can get you in touch with a sales manager from Mexico, and they can explain you all the type of projects that they have developed in Mexico. Then the next one, Claire, is from Arun. How complicated is mixing with concrete, as nesting of fibers can occur and fibers will not be uniform?
So it's one of the, for sure, right? If you mix fibers improperly, the risk of balling is present. However, if you follow our design recommendations and use the tools that we've made available, it should not ball up. So one would be adding the fibers as the last component to the mix, or certainly not the first. So they should be one of the last things added into the wet concrete. And additionally, the Dramix fibers that are above a certain aspect ratio are glued together in a clip. I don't have any right here on me, but they're glued together with a water-soluble glue. And so what happens is, as those clips, they're called little sections of glued fibers, as those clips are distributed into the wet concrete mix, on the macro level, they distribute. And then after about 5 minutes of mixing, the water in that wet concrete mix will dissolve the glue, and each fiber will break off locally. So on the micro level, you'll achieve that uniform and consistent distribution that you're counting on in your design. And that glued approach is something that we've actually patented. It works extremely well. And when that's done, you should not expect to see any problem.
All right, thanks. Then Ashok is asking, how much is overall cost savings in terms of material costs only?
So it really depends. It's very difficult to say across the board that material cost is always going to be ahead, because we typically see that the cost savings will come from not only material costs, but also schedule and labor savings. So you really have to look at it as a total construction cost rather than just material for material. This is actually something that folks have said before is, maybe we're offering a solution with a thinner section with, whatever the dosage is, let's just say 25 pounds per cubic yard of some fiber. And some contractor might come back and say, hey, but the cost of rebar is less than the cost of fibers. So, what gives here? Right. And so that's really a fallacy that you should be mindful of, is that it's not just steel for steel costs, but think about how much time you're saving by having pre-reinforced concrete, by avoiding having to do inspections on the job site, and by potentially having a thinner slab, which means less concrete, fewer trucks coming onto the site, and so on. So it really does have to take into account the entire construction cost.
All right. And then the last question is from Sinan, and he is asking, can we use Dramix to designing sorry, I have troubles with this word. Composite, sorry, apologies. Composite columns and composite columns.
Oh, for composite, I misheard the first part. Columns
and beams.
Beams. Okay, so I'll address columns first. So there is a project that has utilized the Dramix fibers for columns, but that's going to be in addition to whatever other conventional reinforcing, both longitudinal and ties, that's required per code. So the steel fibers can provide the various benefits that we've discussed, right? The crack control, the durability, and so on. But it's not something that in a column element or in a typical beam element that we would recommend replacing any of that conventional and code required reinforcing. So at this current time, it would be an addition to whatever you calculated conventionally, though you can still realize benefits. So that would just depend on, what are the requirements of the project, and is that really indicated?
Okay. One last question from Arun. As I understand, we need trained persons to have this work. What about the cost added into this?
I don't know that there's much training for that. It's possible that there's something about that I don't know, but I think with my team, who talk more with and are more aligned with our contractor partners, concrete ready-mix producers, flooring subcontractors, I don't know that they necessarily have a training protocol for that. It is a service that we provide, that we meet with and align with all of the folks who are going to be actually executing the floors or whatever the project is, to help, with whatever best practices and recommendations we can help with, to, ensure that the project goes smoothly and as well as possible. But I don't know that there's any significant cost or training associated with that. I can check on that. I'll look into it and see if I can find whether there's any data to suggest that is more than I more than I expect it is.
Yeah. Then John, the experience with Dramix reinforced concrete, you treat it like regular concrete when laying the floor?
In many ways, yeah. We take a kind of keep it simple approach to that. Concrete contractors know concrete. They know how to place it and finish it. So again, we are available. We like to align with folks just to make sure that they know, again, recommendations on, for example, when to add the concrete to the mix. But other than that, we are not placing the concrete. And we are not trying to change the basics of concrete placement here. So we still want to see things like a well-graded mix design, for example. So it really, we're not trying to add too much or really any unnecessary complexity to those folks who are currently placing concrete today.
Okay, I think there are no more questions. However, there were a lot of persons who asked us to share your presentation.
Okay, happy to. I will put together probably a follow-up email here with the PDF, so I can happily send that out.
Perfect.
All right, everyone. Well, Mariana, thank you so much for your help with the questions. Everyone, thank you so much for joining today. I really appreciate it. I see we've gone over a few minutes here, but thank you again for your attention and for your great questions. Please do feel free to reach out if you have anything else you'd like to discuss, and have a wonderful rest of your day. Thank you.
Thank you as well. Bye.
Bye-bye.